Good day. This video intended for review. So I'm going to provide answers on chapter 2 to 3 from compilation 4 to 9. Problem 1 about deductive reasoning. Solve for x in the given equation 3 times x plus 4 minus 2x equals 20. Justify your answer. First, given. Then 3 times x plus 3 times 4 is 12. Then bring down all the given. Distributive property. After that, 3x subtracted to 2x plus 12 plus negative 12 equals 20 plus negative 12. APE or additive inverse property. APE means addition property of equality. Whatever you add to the left should be added to the right. Then we have now 3x minus 2x, that is x. Then 20 plus negative 12 is a answer. Problem number 2, do what is asked. For problem 1 to 4, use the inductive method to come up with the right formula. You may use these sites or links for more details or for more instructive presentation. For number 1, what is the 35th term of the given sequence? 3, 6, 11, 18, 27, 38, 51. Answer is a n equals n squared plus 2. Therefore, a of the 35th term equals 35th term squared plus 2 equals 1227. For number 2, what is the 48th term of the sequence? 3, 7, 13, 21, 31, 43, 57. Answer is a of n equals n times n plus 1 plus 1. Therefore, a of the 38th term equals 38 times 38 plus 1 plus 1 equals 2353. For number 3, what is the 40th term of the given sequence? 5, 9, 15, 23, 33, 45, 59. We have a of n equals n plus n squared plus 3. Therefore, a of the 40th term is equals to 40 plus 40 squared plus 3 equals 1643. For problem number 4, what is the 61st term of the sequence 2, 6, 14, 26, 42, 62, 86? A of n equals n plus 1 plus n minus 1 times 2n minus 1. Therefore, a of the 61st equals 61 plus 1 plus 61 minus 1 times 2 times 61 minus 1 equals 7322. For problem number 5, the sum of three consecutive numbers is 129. What is the difference between largest and smallest number? We have x, x plus 1, x plus 2. Smallest, largest. Therefore, x equals 42. Then, smaller is 42. The larger or the largest is 42 plus 2 equals 44.
Then the difference is 2.
Test 2. Fill in the box. Fill in the right truth value on each table below. Let P and Q propositions. For number 1, conjunction, keyword is true only when both P and Q are true. Therefore, these are both true. Then we have true, false, false, false. Number 2, disjunction. Keyword here is false only when both P and Q are false. Otherwise, it is true. Both P, Q are false. Therefore, this is false and the rest are true. Negation. The truth value of the negation is always the reverse of the truth value of the original statement. Therefore, this is true, then it becomes false. This is false, it becomes true. Implication, which is false only when both P is true and Q is false. True, false, then this is false, the rest are true. Biconditional is true only when both P and Q have the same truth values. Here, the same truth values. Here, the same truth values. Therefore, they are both true and the others are false. Problem number 6. Precedence of logical operators or connectives. We have here negation, conjunction, disjunction, implication, and biconditional. So here we have four rows since there are PQ times 2, that is 4 rows. First, because of the left to right method, solve for P, solve for Q, then solve both together. So not P, which means we're going to reverse all the truth values of P. The same thing as not Q. So we have here false, true, false, true. Then or means if it only false when both not P, not Q are false. So here both are false. Therefore, this is false and the rest are true. Number 7, not P and Q or P and not Q. So first, not P, reverse of true, reverse of false. Not Q, reverse of true, reverse of false. Then not P here and Q. We're going to use the conjunction. True only if both not P and Q are true. So here, these are both true, therefore true, the rest are false. After that, not P and not Q. So we're going also use the word conjunction or and. So P, then not Q. Okay, it's only true if both P and not Q are both true. So here we have here true. The rest are false. Only the second row is true. Then after that, we're going to compare this using the disjunction or. The disjunction means it only be false if both this and this are false. So here, both are false, and the rest are not. Final answer. Number 8, construct the truth value of the following. First, count the number of letters. So we have 3, 2 to the power of n, which means 2 to the power of 3 is 8. That's why we have 1, 2, 3, 4, 5, 6, 7, 8. First, divide by 2. So 8 divided by 2, which is 4. Therefore, 4 truths and 4 false. So true, 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 false, 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 false. After that, 4 divided by 2, we have 2. So 2 truths and 2 false. We have here true, true, false, false, true, true, false, false. 2 divide 2, that is 1. 1 true, 1 false. True, false, true, false, true, false, true, false. That is how you solve the first 3 columns. Now, let's go back here. We call conjunctions. So it only be true if both P and Q are true here. So this is true, true, false, 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 false. After that, simply negate it. Just get the converse or opposite of the truth. So or the true. That is false, false, true, 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 true. After that, this and R will be compared using the disjunction. Disjunction means if both F and F, therefore false. Okay, so here it's not both F, here F. Here no more F anymore, therefore the rest are true. That's the final answer. Number 9, the same process. We will count those letters 1, 2, 3. So we have 2 to the power of 3, which is 8. Therefore, 8 divide 2, we have 4 truths and 4 false as the pattern. So true, false. Then 4 truths will be divided again by 2. We have now 2 truths and 2 false as our pattern. Then 2 divided by 2 is 1 true, then 1 false as our pattern. True, false, true, false, true. Then let's go back with the logical operators. We have here conjunction, which means true and true, therefore the answer is true. True and true, that is true. Also true, the rest are false. Then simply negate the R. The opposite of true is false, true, false, true, false. Then we're going to compare this and this using the disjunction or. Against to or, we're going to consider if first is false, the second is false, therefore the answer is false. So false, here false, here false, here is false. Okay, then the rest are opposite. So true, 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 true. So therefore we can write it as true, true, false, true, false, true, false, true. Final answer. For number 10, we need to consider the following statements and determine the truth values. 5 is an integer, that is true. Square root of 3 is an integer, that is false. That is false, that is rational number. 2 divides 4, which means 2 divides 4 is the same as 4 equals 2 times 2, which is true. Now, number 10, 2 divides 4 or 5 is an integer and 2 divides 4. This is how we translate these logical operations into word. So since this is true, this is false, and this is true, we're going to use the conjunction, the disjunction, that is or, which means only false if both are false. So the answer is true. The conjunction and, which means if both are true, then the answer is true. So here is true, the R is true, therefore here is true. Final answer. For number 11, 5 is an integer and square root of 3 is an integer and 2 divides 4. This is how you interpret these logical equations. So the same truth values, we are true, false, we have true, false, and not P, so that is false. Not P, we're going to use the conjunction and. So if this is both are true, then the answer is true. Here it's false, therefore automatic, that is false. Then here is false, we're going to use again the conjunction. So expectedly, the answer is false. Test 3, translation. Suppose we have the following statements for P and Q. P, 3 is not an even integer. Q, the square root of 4 is even. Translate the statements based on the logical operators respectively. So implication, that is if then, we're going to put if. Then copy the P, which is 3 is not an even integer. 3 is not an even integer. Then we're going to use the then because that is conditional. Then Q, okay, the square root, okay, the square root of 4 is even. Next, converse. If Q, then P. Simply get the converse of this implication. We have here now if the square root of 4 is even, then 3 is not an even integer. Number 3, inverse. Simply just negate the implication. Not and not become positive. It will become if 3 is an even integer, then the square root of 4 that negates the Q is not even. That's it. Number 4, contrapositive. Simply negate the converse. So here, if the square root of 4 is even, it becomes if the square root of 4 is not even, then 3 is not. So not and not become positive. Then 3 is an even integer. Okay, that is how we solve translation from 1 to 4.
Thank you.